Hello, this is John Melendez, and this is a presentation of Chapter 10. To begin with, we're going to start looking at correlation and the definition of it. Now, the correlation is basically a relationship between two variables. What kind of variables are you talking about? Well, let's say that you worked in Wall Street and you wanted to see what is the gross national product, let's say that you're working for a company and the company is producing something. You want to know what the product output is. You want to know what the labor costs are and all of those things, and you want to correlate them to your stock prices. We will look at the variables and we will find if there's a relationship between the two variables. Let's say that you're in medicine. You find a correlation exists between two things. Maybe a food item and some kind of allergen. Or maybe that you have a drug interaction and a drug. You want to know what kind of correlation it is. Correlation is the first step to investigation. You want to find out if two variables are actually related to each other. After that, you might start looking at experiments and other things. But correlation is the beginning of all of that. Now, let's talk about scatter plots. The scatter plots are basically the same thing you've had before in math. It's just basically an x and y plot. Basically is you're looking at the relationship between two quantitative variables. So when you put them on, you plot them, you get a line of some sort. You're plotting all these points. Now, if the points look like they're getting closer to a line, then that's a linear correlation. And it's a positive correlation is if x goes up, then y goes up. If you see an increasing pattern, then you have a positive correlation. Now, if you said the opposite, let's say that as x increases, then y decreases, then you would have a negative correlation. And if it's all over the place, then you have no correlation at all. So now, let's talk about this one. Since it's all lined up, that's a negative perfect linear correlation. And on the other one, the farther away they are, the looser it is, or the less correlation you have. Okay? So as you get farther and farther out, then you have a lower and lower correlation. Now, the linear correlation coefficient is basically when you have points that almost look like they could be on a line. So the linear correlation coefficient R, the letter R is important, that's your symbol. It measures the strength and direction of the linear correlation between the pair quantitative x and y values in a sample. So basically R is your sample correlation coefficient. And again, like I said, it measures the relationship between two variables. Okay, so now you need to know these properties for the linear correlation coefficient. Know that R goes between -1 and 1. Okay? Know that R, the closer you are to -1 or +1, the stronger your linear correlation is going to be. And the closer it is to 0, the weaker that correlation is going to be. Now we're also going to round those correlation coefficients to 3 decimal places. And basically that's what we have for the properties of the linear correlation coefficient. Know them, they will be on a test, they will be on the final exam. Now, the next thing we have is the coefficient of determination. The coefficient of determination is basically the proportion of variation in y that is explained versus the total variation. So when we look at this, we have that r squared is never negative. Now, one way to say that r squared is basically if you have an r squared to be 0.95, then you're saying that we are 95% of explained. Okay, so it's that 95% of the variation is explained by the model. So the next thing we have is the regression equation. That's the line of best fit, and is denoted by the regression equation, where y hat is the predictive value for y, and y hat is equal to a plus bx. So a is your intercept and b is your slope. This is what we call the least square line of the line of regression. Okay, so now, again, let me repeat myself, where the value of r squared is a proportion of the variation in y that is explained by the linear relationship between x and y. So the next thing we'll have is going to be examples. Thank you.